Okay, so here we go. So what I was showing everyone is about compound interest twice a year and 4% a year. So it's only 2% every 6 months. And so, as I said previously, I'm not going to test it, but I do want you to understand that you're getting interest, and then you start with the new amount with the interest, and then you multiply by 0.02 and so on. And we did it 4 times. Now, that's a lot of work. This is the formula that works it directly and gets the exact amount that we have from all of that work. So we start with the initial amount, which was $1,000. The 1 actually gets you back your $1,000 because you don't want to throw that away. This actually is a reflection of how much you get each time you compound. So it's 4% divided by 2. And then the exponent is actually 2 times a year multiplied by 2 years. So I put this in the calculator and I get this. So this formula is the direct way to do it. And so what I want you to do is to see the future value. This is actually the formula that works for compound interest, would be that first amount, the principal or the present, the starting value. This is the rate, the yearly rate divided by n, which is how many times a year it's compounded. So when it was compounded twice, this was a 2. When it was compounded monthly, it would have been a 12 there. And then the exponent is n multiplied by t. And so this requires a calculator. Maybe not everybody has one, but then in our particular problem, I used 1,000. The yearly rate was 4%, and it needs to be in that form. It was compounded twice a year, so n is 2, so I'm only getting 2% each time. And then n was also 2, and the time was 2 years. So this boiled down to 1 plus the 2%. The exponent, 2 times 2 is 4. Okay, so 1 plus 2% is 1.02 to the 4th power times 1,000. So you can see, even though, you know, I've done the problem for you, it takes a bit. I'm going to kill that. So I'm going to go 1,000 times 1.02 to the power 4. And I don't know if you can see it, but there it is, 1,082 and 43 cents when you round it. So this works really well. And I just want you to be aware of it, so that most things are done with compound interest. And so there is a formula that gets you straight to the answer. As long as you don't throw much more money into this account. If it's just going to roll for a few years, then you can calculate it. Mortgage payments are done in reverse, but it is compound interest, and so it's going down. So I just wanted you to see it so that you realize it's different from simple interest. And simple interest works with this formula: principal times the rate times the time. This is simple interest, and this is the one we will test on. So this is the principal amount, whatever the dollar amount is. This is the rate, probably written as a decimal, and this is the time. And the only thing that's required here is these need to match in units. So this, if this is 5% a year, this would have to be how many years? So these are a match. So years for this and years for that. It could be done, what's the rate per month, and then how many months, but typically it's done where they're both in years. And this, of course, would be a dollar amount. Okay. Did anybody run into any questions as far as homework is concerned? And I can do that. And then I thought what I do is work through a practice test. And then I'm just reminding everybody again, if you're listening to the recording, that the practice test, I mean, the next test is Monday. So it's only chapter 6. The chapter 6 review is due Sunday night so that you're all ready, geared up, ready to go. So anyway, anybody have a question here that they need something that didn't quite work? Okay. I have a series of problems and I'm just going to run through them. And if something else comes up, let me know. So this first one is write each percent as a decimal. Okay, so that's the instruction. There's a number of problems. The first one is 18%, 4%, and 0.5%. So they all carry the same instruction. So these are percents, they need to be decimals. Anybody have an answer for this one?
0.18.
Yeah, 0.18. Okay, so the percent comes off, the decimal is here, goes back 2 places, so it's 0.18. You can throw in that front 0, although it doesn't seem like they mark you wrong for not having it. But then they give you a reminder, oh, that 0 would be really great. Okay, what about this one? Percent comes off.
0.04.
What is it?
0.04.
Correct. Okay, so it's the same doggone thing. It's just you had to add a 0 to get your 2 places in. Now, don't freak out on this one because it's the same exact thing. We have to move it 2 places to the left.
50%.
1, nope, 1, 2. It's the same exact,
Oh,
0.005.
I see.
So this original problem was 0.5%. So the reason it can't be 50% is this is a fraction of 1%. So it's really small. This is much bigger. 18 is much bigger than 0.5%. And so it's the same exact approach. And so if you have notes, remember this chart, fraction, decimal, percent. So we had percents that were going to decimals. The order of this chart helps you remember which way to go. And from here to here is to the left, and it's 2 decimal places to the left. And so that's what we did every time. 1, 2, 1, 2, and even this crazy one, 1, 2. How's that? Okay. So this is a help, actually. Here's the next group. Write each decimal, DC. Boy, I can't do anything today. As a percent. So it's a decimal and it goes to a percent. So here's my first one. So these are easy now. So each one is a decimal and they need to go to a percent. Anybody on this one? Exact reverse, right?
45.
45. And they'll probably they'll probably expect you to put 45 in here, and they'll probably have either a percent symbol or the, word percent there. And so don't insert it here because I think they'd get confused. How about this one?
70.
70 it is. And this one?
135.
Yes. And so see, once back to this, my little chart, when you had decimals and needed to make it a percent, it's this direction and it's 2 places to the right because percent is always 2 because it's 100. Let's take a look at this one. Write each percent to either a mixed number or a fraction, I guess. And anytime it's fractions, there's always that implication that it's reduced, whether it says so or not. So here's my first one, 65%. And you can try these while we're doing it. Okay. This one. So this is making it a fraction. So some of these are pretty easy to do. 65% as a fraction would be 65
Over 100.
over 100. You're still left with the job of reducing it because they're not going to think that's right. I'm going to reduce by 5 because I can see 5 would be a good shot. 5 into 6 is 1. 1 left over. 5 into 15 is 3. I like that. 13. That looks like a good number. 5 into 10 is 2. 5 into 0 is 0. You think that's reduced?
Yes.
I do too. Let's try this one. So it's the same thing. So these 146 over 100. You look at these two, and I don't think this is reduced because they're both even, which means they could at least divide by 2. So I'm going to divide by 2 and see what happens. It'll probably be better at least. 2 into 14 is 7. 2, none left over. 2 into 6 is 3. I suspect 73 doesn't go anywhere. I like that. I think we might be done. And then 2 into 100
50.
is 50. Now, they wanted, the instructions up here said mixed number. Okay.
3 and 1/5.
So this is 73 divided by 50. If you need to, 73 divided by 50, if you need to, and I was showing somebody this recently, turn this into a division problem, the 73 over 50, which means the 73 comes down. And I'm going to add a couple zeros. So it's really 50 into 73. This one comes up. Actually, I want a fraction. So it's 1. 1 times 50 is 50. I didn't need those. And how many left over? 23. So what we have is 1. And they did want a mixed number, so I got carried away with my decimal. 1 and 23 over 50. Okay, so we had it right here. We divided it. It went in one time with the 23 left over the 50. So that, do you think that reduces? I don't think it goes anywhere, do you? 23 is no good. Okay. Now, we've dealt with this before, and we can deal with it in the same exact way as these others, except it has that decimal thing. So I'm going to go 3.5 divided by 100. That's no good. the simplest thing to do is to clear that decimal. And so it needs to be shifted 1 to the right, which amounts to multiplying by 10. But you can't just do one and not the other. So you've got to do it to both. And so that's, I think, the simplest move for you is to move this to the right, which would make this 35. But we have to match it here so that it doesn't change. So the decimal on 100 is there. We have to move it to the right 1. So it would be 1,000. Well, that's at least decent. Both are whole numbers, but they need to be reduced. And I'm thinking 5 again. Don't you? So 5 into 35 goes 7. And then 5 into 10 goes 2 with 2 more zeros. Okay. That doesn't go anywhere, does it? I think that's the simplest way to clear the decimals so that you're working with whole numbers and then work it down, reduce it down the best you can. Okay? I think that was our best plan on that one. Here's our next batch. Here we go. Write each as a percent. So there's a mix here. So this is 7/20. This is similar to the last one. This is 3/8. And this is 1 3/4. Oh my. So each one of these needs to be a percent. Now, I want to go back to my lovely little chart to make a point. Each one of these was a fraction, and it needed to go to a percent. And so sometimes, probably most of the time, it's easier to take the fraction to a decimal first and then to a percent. In other words, follow the path, the road, so to speak, from here to here. And then when you get a decimal, that decimal shift is just the 2 places. So this is teaching a lot, this silly little chart. So back to this one. This one can be divided out. And so remember how I'm encouraging you to do it so that you don't switch your numbers. And guess what happened? Ah. There we go. So I'm dividing this out. And this is a whole number. So this decimal can come straight up. So it's going 20 into 70, 3, 60, and then 10 left over. Bring this down, and 20 into 100 is 5. 5 times 20 is 100. Well, that's good. So that 7/20 became 0.35. Now we have an easy shot at making it a percent. Answer?
35%.
35%. Okay. There was another way to do this, but I'm going to do this one next. 3/8. 3 divided by 8. I am going the fraction way, and I'm bringing my decimal up. 8 into 30 goes 3 times. This is 24. I'm subtracting and getting 6, and this is coming down. 8 into 60 is 7. That's 56. I know how this is going to turn out. This is going to be 4 left over. 1 more 0 will finish this off. 8 into 40 goes 5. 5 times 8, 40. no remainder, that's what we like. So 3/8 is 0.375. I need a percent. Anybody?
37.5%.
Yeah, 37.5%. Okay. Now, maybe you know what 3/4 is. You might. 3/4 is 75 cents money. You may know that this is 1.75. Do you know that? You might. If you do, then you're ready to roll because we now have it as a decimal without any sweat here. And we move it over 2 places and we're talking 175%. Why is it over 100%? Because this was over 1. Can things be over 100%? Easy. Cost of all kinds of things could be over 100%. And so that would be that. If you didn't know that fact, then probably you would have to go 4 times 1 is 4 and 3 is 7/4, making it, see, this fraction is easier to compute. If you did not know what this was, you would divide it out. This is 1, 7, 28, 2 left over, 4 into 20 is 5. So there's the 1.75, 2 places that would have done it. I did say that this one could have been done differently, and it all depends on where you are with this. You need something to do that'll work every time. But because I saw 20 and I knew I could convert it into a 100, and I'm trying to make a percent, if I multiply both by 5, 20 by 5 is 100, 7 by 5 is 35. And if you recall, the answer then, this is the percent, 35%. This only works with this problem because the 20 could easily be converted into 100. And so that would have been a shortcut. But this method will work on problems like this, where 8 does not go into 100 nicely. I don't know about this one. This is sort of weird. But this method will work every time, dividing it out, making a decimal. In other words, it's back to my little chart. The fraction became the decimal became the percent. And so when you had to jump to, it can't get from here to here most of the time without going through a decimal. Any questions about that? Does that work?
Yeah, some of the answers, like in the middle, 37.5.
Yes.
And the answer they gave me wrong because they didn't say 37.5.
They wanted a half?
Yeah, one of them, one of the answers.
Oh, let me see. If that happens, send me a message. Now, if the instructions clearly said, we want this with a mixed number, you see what I mean?
Yeah.
So if they said mixed number, then 37.5 as a percent would have been a mixed number.
Okay.
This is a correct answer. I think, I think I'd probably give you credit for that. So if things like that happen, let me know. But I mean, they really did, if they specifically said mixed number, then technically this is the better answer. I can't see a big difference between the two.
Yeah.
I mean, I really,
That's
but
why I
you're
thought-
right. Thank you for bringing that up because that's worth something. We don't want to, And sometimes it looks like you're totally wrong when you were totally right. And so I can clean up those kind of errors. Okay? Yeah. So if you can, call my attention to it, that would be just great. Okay, so this is what I call simple percent problem. What number is 75% of 60? The way I taught it when we did this was to turn it into an equation. Now, after tutoring a couple of people over the last few days, I found out that a lot of people are just happier with the proportion, especially on word problems. This particular type goes easily into a simple equation. And so I still think that the simple equation is the path of least resistance, which I'm trying to help you with. But I'm going to do it two ways, and then you pick. And I'll talk to that more about when we get into more a word problem. But this one translates real easy. What number X equals 75%, 0.75 of times 60. So I think this is a clear way to do this problem that doesn't require a lot of angst. And so you multiply 60 times 0.75 and you get 45. You can do it. 0, 30, 0, 42, 0, 0, 5, 4. 1, 2, 1, 2. Okay? Does anybody here want to do it as a proportion, or is this seem like a good way to go?
I like it.
I like the proportions when things are confusing. I think
Okay.
that like if there's a bunch of problems that you have to do,
Yeah.
proportions are like the solid way because it answers all of the problems. But if you're looking at it straightforward, like this is the only equation you have to look at, 75% of 60, that's easy, 0.75
Yeah.
times 60.
Yeah, I think so. And if somebody wants to see this as a proportion, but I think they kind of call it basic percent problems, where it's not a word problem at all. It's just da 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 like that. I think this might be the easiest way, but I'll show you the other one. Here's the next one. What percent of 40 is 18? Now this looks a little bit different, but it's the same as the previous problem. What percent, you don't know, so I'm going to call it X, of times 40 equals 18. This translation from this sentence to this mathematical equation is good practice for what's coming up in your next course. And so it doesn't hurt one bit if you can tolerate it. Translate. There's no big deal. So we have X times 40. We need to get rid of the 40. So I'm going to divide it by 40 and divide this by 40. X equals. So it's 18 over 40, but that's not a percent, is it? In fact, it's not even reduced. So I'm going to divide, let's just divide by 2. 2 into 18 is 9, and 2 into 40 is 20. I still need a percent, but I've got a decent fraction rather, and I want to make it a percent. That's what we were doing on the previous problems. 9 over 20 needs to be a percent. And so You can divide this out
45.
and it is 45. This is 4. So as a decimal, it's 0.45, which is 45%. Okay. So I think that one's okay. You still have skills where you ended up with a fraction, but you needed to make it a percent. You actually know how to do that. And that's the thing about percents. You've got to go back and forth between fractions and decimals and percents, and so on. Let's look at this one. 16 is 20% of what number? Translation. 16 equals 20%. I'm going to go straight to the decimal of times what number? The goal is to get X alone so that you can report the answer. It's multiplied by 0.20. So what you do is you divide both sides by the same thing so that this cancels down to 1x, which we'll call X. And this, it's up to you to figure it out. And so that's why we learned these skills. So it's 16 divided by 0.20. I'm going to make it a fraction into a division problem. The 16 comes down. And so this is ignored. The trouble with this is it has a decimal in the divisor. And so this is the case where you have to move it over to clear it. And you have to match it over here. So what this problem ends up being is 20 into 1600. Okay, 1, 2, 1, 2. So 20 doesn't go into 16, but it will go into 160, which is 8. And then 20 into 0 is 0. So the answer is 80. Okay, the decimal was there. Any question about that? The minute you do a problem, the minute I do a problem, I can say, oh, I would have been better off doing another way. But I mean, how many ways do you want to do it so that you can figure out the most perfect way to do a problem? You don't, do you? You want to have a consistent way to do things. And so this could work. Now, I'm going to ask again, does anybody want to do this as a proportion or not? Anybody? Okay, we seem satisfied. Okay, here's a problem about test scores. So on a driver's test, the student answered correctly 23 out of the 25 test, 25 question test. What percent is this? What percent was answered correctly? So you've all taken driver's tests, right? Or most of you have. Have you? Do you remember it? Taking your driver's test? This is the written test, but I was thinking about the actual driving test. I'm going to do this one as a proportion. It's a word problem. The percent goes here and we don't have it. You can either say P for percent or X. This is always 100, so you don't have to think. The next thing you do, once you've settled this, if you had a percent, you would have written it in, but we don't, because that's what we're actually after. Can you tell me the total which goes on the bottom? What?
25.
It's 25. And the minute you've nailed the total, then the 23 is the part. And so now you're ready to roll. So this is where, when we do a final and I look at your work, if I see this much, even if it goes bad, this is the hard part. So 23 times 100 is 2,300 equals, be sure and say equals, 25 times P. To finish this, I have to divide by 25, divide by 25, P equals, well, 25 into 2,300. 25 doesn't go into 23, but it will go into 230. Think if this is money, this will help you. Think of quarters. How many quarters in $2.30? 4 for the first dollar, 4 for the second dollar, and 1 more for that last bit. 4, it'd be 9, wouldn't it? 9 times 25 is 225. When you subtract, it's a 5, and you bring this little 0 down. 25 into 50 is 2. The percent is 92. 92%. Now, that would be the correct answer, 92%. Do you see that 25 goes into 100?
4 times.
4 times. The answer actually becomes 23 times 4. Let's just try it, just so that you can see this. 4 times 3 is 12, carry a 1. 4 times 2 is 8, and 1 is, there you are.
Mm.
Some things just pan out and some things don't, but this setup will work for even the lousy problems. And so this is what you need to be aware of, okay? Test scores, he got, whoever it was, got 92%. This next question is about commission. The salesperson, oh my gosh. I went into a store yesterday to look at flooring because of construction. And believe me, they came looking for me to help me out. And the person gave me their card. I don't know if this is true about flooring, but on this particular problem, they get 8% commission rate of the sale. So that's really worth talking to the person, isn't it? The salesperson sells $12,000. Oh, computers in one day. What's the commission? The commission is the dollar amount. So you could say it's 8%, but it's 8% of what? Right? So let's set this baby up. So I would suggest, as a proportion, deal with the percent first. Can anybody put the numbers in here?
8 over that one. That one's X or P or C or whatever letter
It
you want to
is,
give it.
but we actually know it this time. Yes. So what number do I put in?
Oh, you're talking about the 8%? It would be 8 over 100.
8 over 100. That's all I needed. You're right. So this is the percent, and this is always 100. But they gave it to us, so we took care of that business. The next part is, can you tell me the total?
12,000.
12,000. And so 12,000 goes right here, which means there's your X. So this is the rate, the percentage rate of commission. This will be the amount of the commission. And so cross multiply. So this, I'm going to go 100 times X. I put the 100 first. This is 8 times 12,000. 1, 2, 3. This is 1696. 96,000. Now what? Are we done? Are we there yet?
No,
Take out those last two zeros on the 96,000.
Yes, so we're gonna divide both of them by 100. We're gonna kill a couple of zeros, and so this is 960 over 1. My goodness, that was worth it to talk to that person. What do you say? That's commission. See, they're paid. I mean, they probably have an hourly wage. I guess this is kind of explaining there's a markup on things.
yeah,
If there's $960 available to give to the salesperson, you see how this works? See how they're so friendly and nice to you?
yeah,
I'm being facetious. People deserve a right to have a living. But I want you to, I think this is a significant amount of money. What do you say? It's a good amount. All right. So that would be the answer for there. So that's $960. Here's a number about sale price. And so this is another example. A tennis racket normally sells, so this is a really good one. The normal sale price is $280. It's on sale for 25% off. Okay, so that's going to take a good bit off of this. They threw in an extra thing here. There's this, the tax rate is 5%. So, you know, they're going to add that on at the end, but let's keep that in mind. What is the total price of the tennis racket if it's purchased during the sale? Okay, so we're going to get the sale price, but we're also going to have the tax rate, which is 5%. So let's deal with the sale price first. So the percent is on the over here. And so you do it the same way every time. You don't get creative on me. Well, you could, but I don't recommend it. What number goes here and what number goes here? There's a trickiness to this problem. What number goes here?
We want 25%, so 25 over 100.
Okay. Good job. Now, what's the total?
280.
280, and goes which place?
bottom,
Bottom. Total on the bottom, which means there you are. So I'm going to cross multiply. This is 100 times X equals 280 times 25. Ooh, how much is that? Anybody have it? 7,000. I cheated, by the way. Okay. So if we divide by 100 and divide by 100, 2 zeros, hit the dust, 70. My question is that the price of the racket?
no,
It's not. You think about this. We did the calculation. This is the percent that's off. So 25% off. And when we calculated for X, we get $70. This is how much is off. So don't be tricked just because you got an answer that's what you're going to use. It's not $70 at all. It's 280 subtract 70, which is $210. At least it's a better price, but that's the sale price.
and then
What? And then they're going to put this on automatically. Let's do the calculation. So if our price is $210, which we did figure out, and we have to add that 5% tax. Okay? All right. We could do this with a proportion. We could do this just taking, I'm almost tempted, 5% of 210. That would also work. 10 times 0.05.
Okay.
That's what I'm getting that way. If I do it this way, 5 over 100 for the 5%, the total is 210. This would be X. You would cross multiply, but X again would be this. The question was, how much do they pay total when they buy it on sale? That means including the tax. So
With
what is your
2050.
answer?
You add it,
Do what?
add it,
Okay, add what to what?
1050 to 10.
210, exactly. 210 to 1050. There's your tax. You'll see it on the receipt for sure. It'll be there. So this is $220.50. That's your answer. Okay. So we did it in 2 steps. We had to figure out the sale price, which turned out to be 210. That was better. And then we applied 5% to that 210. I thought this might have been the easier way to do it. What do I know? Not much. Okay. Okay, so that kind of thing could come up. How's our time? Simple interest, here it is. $5,000 is invested at 8% simple interest for 3 months. Oh, this is interesting. How much interest is earned? Okay, we put $5,000 in an account that pays 8%, which is assumed a year,
Oh,
but we only leave it there for 3 months. Oh, I'm going to write the formula. Interest equals principal times the rate times the time. Now, I don't know if you remember my page where, I hope I can find it. No, it's not there. It's one of the first things I did. No, I lost
what
it.
I do the 8% out of 5,000 divided by 12,
Almost.
and then
You're in the right ballpark, because this 3 months is not a full, it's not 3. If I put 3 down here, I'm going to get too much. It's only a fractional part of a year. This is clearly 5,000, so that there's no argument on that. The rate is 8%. So this is in terms of years. If I put in 8% over here, I better make this in terms, my time in terms of years. How do I do it? 3 months is not a full year. 3 months out of 12 months is actually a fourth of a year. So to get this to match up, like I was talking about earlier, this needs to be 3 over 12, which I'm going to write as a fourth of a year. If these match, it's going to work. So then you could multiply these two. So that's 5,000 times 0.08. Anybody get an answer yet? So it's 3 zeros, and then 8 times 5 is 40. The decimal moves over 2. So that's 400. 400 multiplied by 1/4. So I did these two first and got 400. I threw the extra zeros away. And then the ones that after the decimal point, and then multiplied that by 1/4. I would cancel this. 4 into 400 is 100. So 100 times 1 is 100. So that is our answer. We earned $100 interest in those 3 months. How do you like it? Okay, this was a good problem because it wasn't like 3 years where you could just drop in 3. It was 3 months, and so you had to actually adapt this, and this was the example. Okay. Now, if there's a problem on compound interest in any of your work, either your homework or something, you don't have to do it. I'm going to write the formula down. Let's see, how's our time? Principal times 1 plus R over N to the NT. One of the reasons that we go from arithmetic to algebra is so that if somebody gives us a formula, and I don't care what the formula is about, it could be about, in this case, it's about interest. It could be about, how long does it take for something that's dropped to fall down? How long? I once had somebody that did accident reconstruction. I think he was in the police force or something. And so he had to do computations about this. So they'd go and they'd look at the accident and they'd see when did the person hit the brakes, and you can actually calculate their speed based on how long it took for them to get the car stopped. And so there's formulas for every darn thing you could imagine. And so the question is, can you take the numbers given and correctly put it into a formula using order of operation? Right? That's what we've been learning. What's first, what's second? Can you correctly insert the formulas in so that you can come up with a correct answer? And so learning to do some algebra, learning to eventually use a calculator, in this case it's required, can get you a long way. So literally, if you knew what each letter stood for, you wouldn't even need to know what the formula was about. In our case, this case, principal was $12,000. So I know I'm going to put it here. I'm not expecting you to learn this, but I'm expecting you to get the concept of inserting numbers into the formula. That's what I'm interested in. That's what we'll eventually do. If I told you that R is 2, if N is 1, and if time is 2. So if I told you all of those things, could you place it into the formula? Carefully. This is where you have the formula in front of you written correctly, and you carefully insert every number in its place, simplify it the best you can, and then pull out that calculator. So in this case, it's 12,000 for here. It's 1 plus R is actually 0.02. N is 1. I corrected that. N is 1 and T is 2. See what I did? So I corrected this. This is my mistake. 0.02 was a rate. And so then, see, this is the skill. So it's 1 plus 0.02 is 1.02. And then this is the exponent, this number times this number. So 1 times 2 is 2. This will then it's as simple as possible. Everything has been correctly inserted. And so then when you're learning to use your calculator, you're good to go. So 12. So, I'm going to clear this. 12,000 times 1.02. This is the power key on my calculator, to the power 2. Is that? Enter. Okay. So that's the correct answer, $12,484, and that would 0.8 would be 80 cents. Okay. So my point was not to teach this, but to get you to appreciate what you're going to end up doing. And it's like, are you careful? Are you careful to put the numbers in correctly, just like before where we were doing the percent problems? Did you carefully figure out which was the total? Did you carefully figure out which number goes where and then do the computation? Okay, so we're going to let this go, but I want you to be aware that there's a beautiful formula that works and saves a ton of time. Okay. All righty, what else? I think it's I'm going to stop. I think I'm going to
Thank you.
Thanks. So let me kill this.